Hey guys, I thought I'd make a quick video to show you how to calculate your head speed for the Hobbywing ESCs. I'm fairly new to this, so I ended up having to watch several videos. Freddie makes some wonderful videos. The first one is about how to program the ESC, and this is the actual link here, and this is the video, Hobbywing ESC programming it, and he explains great how to do that. So then the next step is how to calibrate the throttle. And if you're using a Beast X like me, you need a little bit of a workaround. Although I just downloaded version 5.1.3, and it seems to send the information to the ESC quicker, so I actually don't need to use his workaround. But that's a step if you need it. And then the final step is to go to the field and do a governor calibration, which he explains here in this video. And this is a great video, shows you how to get this number here. So then the question is, what do you do with this information once that's been done? And I was able to figure that out going through the manual. Has this, where is it? Here it is. This calculation here, which isn't explained very well. So I thought I'd try to show it to you real quick. All right, so let me come back over here. So let's say you get done. We'll use Freddie as an example. You get done and you get this 108 times 1,000. So what do you do with that? So the first thing you want to do is you want to calculate the maximum RPM. So you do the governor calibration, which you came up with, the 108. Then you divide it by the motors, divided by motor poles, divided by 2. And then divide that by the gear ratio, which is the main gear teeth, divided by the pinion number of teeth. So if you're rusty in your math, you have to do these things in the parentheses first, or otherwise it won't work. So the way this works is it's 108 times 1,000 divided by, then just stick your numbers in here. If you go, Freddie was using an X-Nova Lightning motor, and those all pretty much have 8 poles right here. So that's what got stuck in right there. And then I believe that he's using a Tron 5.5 helicopter, it looked like. So it looks like those use 135 teeth on their main gear. And then as far as the pinion, looks like they make a bunch of different pinions for this, from 13, 14, 15, 16, 17. Let's just say that he's using a 15T, which is kind of in the middle. So we come back to our formula, and you just stick these numbers in here. 135 for the main teeth divided by 15 pinions. So then if you get your calculator out, you do 108 times 1,000, which will give you 108,000, and then divide that by this result. Actually calculate that first, which is 8 divided by 4, and then calculate this next, 135 divided by 15, which gives you 9. Now you can crunch this together. 108 times 1,000 divided by 4 equals, divided by 9 equals, and you should end up with 3,000 max RPM. So what that means is that's as fast as that thing can go at 100% with a perfectly brand new battery. Of course, we want to leave some headroom for the governor to increase and decrease. So we really don't want to ever run a governor above 85% or 90% for sure. So Freddie has been using 60, 70, 80% curves on his in his transmitter. So what he should be getting at a way you calculate that is you just multiply that percentage times the 3,000. So if he's at 60% flat throttle curve, that'd be 0.6 times the 3,000 max RPM, which gives you 1,800 RPM on his normal mode or his first flight mode. And then his next one is 70%, which is 0.7, which you'd multiply by the 3,000. So his second flight mode should give him 2,100 RPM. And then his final flight mode is 80% or 0.8 times 3,000. So he should be running around at 2,400 head speed, which he said was screaming. So that would be probably pretty accurate. Okay, now another way to do this is to work the other way around and say, I have a head speed that I want. So the formula for that would be take your desired head speed and divide it by the max head speed to get the throttle percentage. So if he wanted a 2,000 RPM head speed, he would just simply divide 2,000 into his max RPM, which is 3,000, and he would get 66.5 is what he should set on his transmitter to get that 2,000 RPM head speed. So let's go with my real life example. I've got a Hobbywing X5 that I did this with. So I did his throttle calibration thing out of the field, and I came up with 103. I have an X-Nova 420 in there, which is 8 poles. I've got a main gear with 120 teeth in it. Scroll up here a little bit. And then I've got a pinion with 13 teeth in it. So to use the formula, I multiplied 103 times 1,000. Again, do the parentheses you have to do first. So 8 poles divided by, whoops, this should be a 2 right here. Okay. And then 120 divided by 13. So you have to do the parentheses again first. So you end up with 103 or 103,000 divided by the 4, and then my ratio, gear ratio, 120 divided by 13 is 9.23. So that all works out to be 2790 is my maximum head speed. So playing with the simulator and different things like that, my flying style, I decided I wanted to have RPMs at 1850, 2000, and 2150. So to get those throttle curves is to simply divide the first one, 1850, divided by the max RPM, which is 2790, which gave me 0.663 on the calculator. So that's going to round to, I'm using an old Spectrum DX7 transmitter, and so those go, here it is right here. I'm going to, so there's my normal flight mode. Those can go to the nearest 5, to the nearest 0.5, and so it's 66.5. Now what I found with a little bit of testing I've done, that this is all with a perfectly charged battery. And so this 102 right here, see if I can get my finger in there. This 103 is a little slightly optimistic. So I found if I used 102, it's more realistic. Or what I did is I just round those up 0.5. So instead of using 66.5, I actually use 67. And that gives me the 1850 RPM. And then for my 2000 head speed, you divide 2000 to 2790, you get 0.716. Again, that rounds to 71.5 in my transmitter. You can see that I've rounded up to 72, just up 0.5. And then finally, for the 2150, if that's my desired head speed, divide that by 2790, you get the calculator gave me a 0.7526. So that rounds actually up to 75.5 flat curve. And then in my transmitter for flight mode, idle up 2, I put in this, I just rounded up a little bit to 76 to get that 2150 head speed. So I hope that's helpful. If you have any questions, you send a thing there on the YouTube post, and I'll try to help you out. And good luck with your flying.